Welcome to 12.2 volumes of prisms and cylinders. In the previous lesson, 12.1, we talked about the surface area of three-dimensional objects like prisms and pyramids. Today we're going to switch over to what are the volumes of these prisms and cylinders. Before we get started, let's go ahead and do the bell work. If you haven't done it, you might want to pause this and give it a shot. Make sure you understand what's happening. And then we'll just go through the answer right now. All right, so when we're determining the surface area, we're finding the surface area of all the two-dimensional objects that make up this shape. As a reminder, a cylinder has a top circle, it has a bottom circle, and it has a rectangle. So let's draw all those shapes. Now remember, what matches up is this radius right here would match up with the radius of each of these circles. So when we find that radius, we'll have both of those. This height right here in green would match this height right here. And I'm also going to note that this length would match up with this length, which is actually the circumference of the circle. So as a reminder, that top width is actually the circumference of that particular circle. So let's see what information they give us from this explanation. So it says the solid cylinder below, got that, has a height of 15 centimeters. So that means that this height right here is 15 centimeters, which also means that this height right here, let's try to do a better 15. I guess we could put the 15 on the other side as well. Cool. So that is our height of 15 centimeters, and it has a radius of the base is 3 centimeters. So if the radius of the base is 3 centimeters, it also means the radius of the top is 3 centimeters. So we can go ahead and fill that information in on our two circles. All right, let's put together our areas. All right, the area of one of our circles would be pi times radius squared, which would be pi times 3 squared, which equals 9 pi. The area of this circle down here would also be 9 pi. So our two circles would be 9 pi plus 9 pi, which would be 18 pi. All right, let's get our one rectangle. Now the area of a rectangle is length times width. Well, we have a width, a height, whatever you want to call it, of 15. We just need to find this kind of mystery length here. Let me just switch up my pen color. Let's go red. I'm trying to find this length right here. But as a reminder, that is our circumference of that circle. Oof, that was terrible. But that is our circumference of our circle. And to find the circumference of something, that's 2 pi r. 2 pi r, which in this case would be 2 pi times our radius, which is 3. So that would be 6 pi. So we're going to have 15 times 6 pi, which is going to equal 90 pi. So our surface area is going to be 18 pi plus 90 pi. Remember, these are centimeters squared, so our end answer is going to be 108 pi centimeters squared. Boom, boom, boom. Done. Got our surface area. All right, so that's what we did yesterday. We did surface area yesterday. Let's talk about volume. Now, yesterday was basically our surface area, so that was how much paint it took to kind of cover it. Today, we're going to talk about how much it takes to actually fill that object up from the inside. Now, one way to look at it is to look at it as a bunch of cubes. You'll hear something like the cubic centimeters of an object. When you have height, width, and base, we're seeing how many of these like 1 unit cubes can be stacked inside of that. That's going to give us our volume. Now, that would result in our length times width times height is going to give me the volume of that particular object. Now this kind of way of thinking about things makes it really easy if you have a cube. However, what if we have a shape that looks like that? Well, it is possible to kind of extend this out, do this, find our length times width times height, and then find our length times width of height of kind of this new box that I drew in here and subtract it from our overall volume. Now, that is possible, but it becomes very complicated when we start applying it to something like a cylinder. Well, Now with a cylinder, if I did length times width times height, here's where we get a problem. This cube around it isn't really helping, but if you picture kind of that cube, you'd come up with length times width times height. It would be really hard to subtract out all that missing area that we don't want to account for. So doing this length times width times height method doesn't always work when we apply it to other shapes. Instead, we're going to think about this slightly different. Now, length times width times height tells you how many kind of cubes you have inside of this box. Now, let's picture it slightly different. A different way to picture this is, well, length times width is just the base of your cube. So we can think of this as being the area of the base times your height. In other words, if I had a cube, and I kind of think about the, I guess, planks or whatever we're stacking up, I want to know, well, what's the area of that? What's our length times width? And then I want to multiply how many of those can I stack on top of each other till I get to the top. So we're dividing kind of two-dimensional objects and stacking them up to become a three-dimensional object. In this case, all we need to do is get our base, which would be length times width, and once again, it's just multiplying by height. Now, it might seem like this is the exact same thing we just did, but this is able to apply to different shapes. All we need to do is get the area of the base and multiply it by how many of these we're going to stack on top of each other. In other words, what is the height? So it's not just length times width times height. Although it applies to this one, really we're thinking, okay, base times height. That's all we're thinking, base times height. Area of the base times the height. So applying that to this shape. This shape right here, what I'm thinking about is, what is the base of this object? What is that shape I can stack on top of itself over and over and over again to get the top? And what I'm kind of picturing is, we kind of see this example here. If I picture that right there, that shape right there, if I kept stacking that up, so if I just kept drawing more of these, maybe another row of it, but you can kind of picture as I keep stacking this up, eventually I'm going to get to the top of that drawing. So that shape I'm going to keep stacking over and over and over again is this shape right here. Let's see, kind of like that. Probably not the greatest. Maybe we could fix that a little bit up. That's even worse. Cool. Well, that I guess is better. But let's put some notes down. So we have a 3, we have an 8 here. If we look at this 9 right here, that's that length there. But that means that's this length here. So that's 9. This is 5. So if we kind of picture this, we could fill in some more information. If this is 8 and this is 5, that's going to make this top one. In fact, let's actually divide that up because we're going to get the area. So this is 8. This is 5. If this is 9 and this is 3, that's going to make this 6. So these are all our measurements. Now, I'm going to call this the base. Now remember, volume equals our area of our base times how many times we're going to stack it. In other words, that's times the height. In this case, what I'm kind of picturing is we're stacking this up kind of like that our height is going to be that 20. So that's my height. I just got to find the area of the base. Well, this is my base. I just need to find the area of this. So let's find the area of each little individual section. So the area of this would be 9 times 8, which would equal 72. This one would be 5 times 6, which equals 30. So our base area equals 30 times 72, which is going to be 102 centimeters squared. So that's my base area multiply it by the type will give me the volume. Not type, but our height. So our area of bases is 102 times our height. Our height is going to be that 20. We're going to stack it going up. And so my height is that 27. I am going to note, if you can picture right now, if I turn this drawing sideways, perhaps I can actually draw it sideways. Give me 1 second. So I just took a picture and put it on its side. What I want to note is my base is still going to be this circle, because I still want to stack that on top of each other, but this way my height is still that 27. I just want to note that your height is not always up, down. It could be left, right. You have to look at what shape is being added over and over and over and over and over to get to our final shape. All right, so we have our base, we have our height. Our volume is our base area. So let's find that first. Our base area, which in this case is a circle, is going to be pi r squared. Our area is going to equal pi r squared, which is pi times our radius, which is 14, squared is going to equal 144 pi. I'm sorry, that is incorrect. That would be if it's 12 times 12. Let's go with 196 pi centimeters squared. All right, to get our volume, we're going to have to do our base area of 196 pi, that's our base area, times our height. Our height in this case is that 27, which is going to equal 5,292 pi centimeters cubed. If any of these numbers seem off, I did pre-calculate them, so there's base must match the side. That's